Hello there, welcome to the A-Level Maths Applied June 2023 paper here on question 6 of the stats section. A medical researcher is studying the number of hours T a patient stays in hospital following a particular operation. The histogram shows the summary of the results for a random sample of 90 patients. Use a histogram to estimate the probability that there are 10 to 30 patients, so the amount of time is between 10 hours to 30 hours. Okay, so what we need to do is we need to work out all of the regions between 10 and 30. So between 10 and 30, and work out how many patients are in between these bars. So the easiest way of doing that is by working out the area of the bar, which is base times height. So this goes from 10 to 12, so that's a base of 2, and a height of 4.2, so that's 8.4. The next is from 12 to 16, which is a base of 4 and a height of 4, which is 16. Between 16 and 20, that's another base of 4 and a height of 3.5, and 4 times 3.5 is 14. And between 20 and 30 is 10, with a height of 1, so that's 10 patients there. So our probability is going to be 8.4, add 16.16, add 14, add 10, out of the total number of patients, which is 90, and we get an answer there of, let's grab my calculator and put that all in, 8.4, add 16, add 14, add 10, divided by 90, which gives an answer of 0.538. There we are, so 0.538. Moving on to part B now. So of these 90 patients, the time spent in hospital following the operation had a mean of 14.9 hours, standard deviation of 9.3. Thomas suggests that T can be modelled by a normal distribution. 14.9 is the mean, 9.3 squared is the variance. With a suitable reference to the histogram, state, giving a reason, whether or not Thomas's model could be suitable. So if we look back at the histogram, we can see that the data, if we were to draw a line through it, is skewed to one side, and the normal distribution is symmetric. So no, the model is not accurate because, and we've got to state giving a reason with reference to the histogram, because the histogram is skewed, whereas a normal distribution is symmetric. And there we are, that's the answer to part B. Okay, moving on to part C. Zhang suggests that the frequency polygon based on this histogram could be modelled by a curve with the equation y equals kx e to the minus x between 0 to 4, where x is measured in tens of hours and k is constant. Use algebraic integration to show that the integral from 0 to n of x e to the minus x dx is equal to 1 minus n plus 1 e to the minus n. Fantastic, some integration. So from 0 to n of x e to the minus x dx. Okay, we're going to be doing this by integration by parts. So u equals x, and dv by dx is e to the minus x. We differentiate it to 1 and integrate it to minus e to the minus x. And now we're going to so then we're going to follow the rule for integration by parts, which is x e to the minus x. Take away the integral of du by dx times v. So that's 1 times minus e to the minus x. There's a minus in there, so I'm going to move that to the front of the integral, and then after that integrate, so it's minus x e to the minus x, take away e to the minus x, and all of that is now going to be in between the limits of n to 0. So substitute n in, so it's going to be minus n e to the minus n, minus e to the minus n, take away 0 substituted in, the first term will be 0, so it will be minus e to the 0. Expands those brackets, so it's minus n e to the minus n, minus e to the minus n, double negative here, add 1, And the final thing I think I'm going to do is now move the 1 to the front and subtract. Let's factorize e to the minus n first. So that's going to be minus n minus 1. And the final step then is I'm going to move out a negative from this bracket to the front. So it'll be minus n plus 1 e to the minus n as required. Fantastic, excellent. So that's okay, so show that for Zhang's model, k equals 99 to the nearest integer. Okay, so let's just write down what we've just done in part C. We've shown that x times e to the minus x integrated between n to 0 is equal to 1 minus n plus 1 e to the minus x. So let's go back to what Zhang has suggested. Zhang has suggested that between 0 to 4, so I think our integral is going to be between 0 to 4, kx e to the minus x will equal this expression here. And if we go back to our histogram, we can see that the area under this curve is going to represent everyone in our survey, or all of the sample, which is 90 patients. So now what we're going to do, the area under this curve needs to equal 90. So what we're going to do here, that's an n, is substitute n with 4, and the answer to that is going to be 90 because the area under that histogram equals 90. So 1 minus 4 add 1 times e to the minus 4 is equal to 90. And we need to multiply this all by k. So k was what Zhang suggested. So all of this now needs to be multiplied by k. That all needs to be multiplied by k. And now we can work out what k is equal to, because Zhang suggested that the model was k x e to the minus x. So in the calculator now, it's going 1 minus 5 times e to the minus 4. And that gives me 0.908. So it's k times 0.908 equals 90. And now when I divide that 0.908 onto the other side, 90 divided by answer gives me 99.073. So therefore, k equals 99 to the nearest integer. Excellent. For part E now, estimate the probability between 10 to 30 using Thomas's model of a normal distribution normal distribution of mean 14.9 and 9.3 squared. So let's go to the calculator for that. So we want the lower bound to be 10, upper bounds to be 30, standard deviation 9.3, mean 14.9. So the answer to D is going to, so the answer to E part I is going to be 0.649. Fantastic. That's a bit different to the previous one, which was 0.538, but okay. And Zhang's curve with the equation 99x e to the minus x, and your answer to part C. So in that part, we're going to be doing the integration of 1 to 3, because it's measured in tens, remember, of x e to the minus x, or 99 x e to the minus x dx. And we know that that's going to give us 99 times, so the upper limit is going to be 1 minus 3 plus 1 e to the minus 3, take away 1 minus 1 substituted in, so that's 1 add 1 e to the minus 1. And if we type that all into the calculator, that will tell us the number of people that we expect between 10 and 30, and then we'll have to divide it by 90. So 1 minus 4 e to the minus 3, take away 1 add 2 times e to the minus 1, which gives us 99 times 0.537 or 66 ... But then that's going to get times by 99 at the front, but then that's going to tell us how many people are between 10 and 30. So the probability is going to be then divided by 90 because there are 90 patients. So times 99 divided by 90, and we get 0.590. So there we are, that's the answer to part II. The researcher decides to use Zhang's curve to model a probability between A and B. State one limitation of Zhang's model, and the limitation there is that the patients may stay longer than 40 hours. That's what the mask scheme recommends. Okay, so there we are. That's the answer to question 6, a very tricky stats question there. Hopefully that's all made sense though, and thanks for watching.